Hi, welcome to operations on the heap. Heap in the sense, for example, in real time, we may see the fruits or vegetables are arranged in the form of uh, this heap. So that's why it is coming as a name with the heap. So here you look at that. So which is arranging in the form of some order. So this order is following structural property. So the structure should be almost complete binary tree, and the second one is heap property. So here either we are following the min heap or max heap property. So based upon the type of the heap. So first we have to create the heap, that may be max heap or min heap. In this session we will see how to create the max heap from the given unordered array. We will build the we will call the build max heap method in the Java, and after constructing the max heap, we should follow the max heap property. That means parent node. Whenever you are constructing the heap, you should follow the heap property and structure property. So heap property for the max heap is a parent value always greater than or equal to its children value. So this heap property should maintain when we are creating the heap. After that, we have to apply the deletion operation. So the deletion, from when you are deleting the node, we can construct the sorting approach to sort out the data in ascending order or descending order. So in the max heap we will follow the sorting descending order. So now how to create the heap. So the given array is having 10 elements. So from the this is unordered array, or the data is arranged in unorder. So now we have to build a tree. So that building the tree is called heapify in the heap method. So inserting a node in the leaf, that means using the structure property, we have to insert the node from left to right to construct the tree. Then adjust the value based upon the heap property. So when you are inserting the node, you should follow the structure property. After that we should compare with parent value based upon the max heap property. Then convert an array a of 1 to n into the max heap. Max heap size always should be the length of the equal to length of the array. The elements in the subarray a of n by 2 plus 1 to the n. So here the length of the array is 10. So 10 by 2 plus 1. So 5 plus 1 equal to 6. 6 to the index value 10. These values always will be the leaf nodes. So here look at that index value 6, 7, 8, 9, 10 are leaf nodes in the given tree. So apply the max heapify on the elements from 1 to n by 2, 1 to 5. Okay, that is the thing we have to do in the building max heap. So first we are calling the method max heap for given array A. So we are initially assigning the length of the array into n, that is 10. We are starting from n by 2 because we don't need to transit the leaf nodes. When you are accessing this parent, always we can check with the leaf node, so that is sufficient. No need to check the leaf node with the null values. That's why we are starting from 1 to n by 2. So first we are accessing the n by 2. So fifth node we are accessing, that will transit until 1. Then we will decrement the index value by 1 by 1. So in the max heapify we should check the heap property. So we are passing the value 5. 5 is, I mean, entire array, then I is 5, then n value is 10. So now you look at that, we are passing that here, the value passing here, then here we will, here different example considered. Index value 1 is the I and n is the 5, right? So here we have inserted the node at last index, that is the 16. So whenever we are inserting the node, we should check the heap property. Parent node is either greater or smaller. If the parent node is smaller than its child, we have to do the movement, that is left and right subtrees of the node I should follow the max heap property. So if it if the parent node is smaller than its child, then we have to swap the a larger node value 16 with its parent through moving down the tree. We have to do this until satisfying the heap property, that is max heap property is parent value always greater than or equal to its children value. So in this example, node 16 is 16 is added in the index value 5. This is the last index, so 16 is added here. So now when you are constructing the heap, the 14 is the root. First we will take the 14, so 14 is inserted, then 10 is second node, so that will be inserted as a based upon the structure property. So 2I, so left child is so 14 is here, then we are inserting the node, so 10 will be left child, then the 3 is the next value, so right child is not available, 3 is inserted here, then 8, so left child for the 10 is not available. When you are checking from the root, then we are adding that 8 as a left child to the 10, then 16, so 16 when you are taking from moving down the tree, right child to the 10 is missing, so we have to add here 16. Now when you are checking the heap property, 10 is less than the 16, so it is violating the heap property. When it is violating the heap property, we should make the adjustment, that is swapping this 10 and 16, swapping this 10 and 16. So for that we have to call the max heapify. In the max heapify, we are passing the value here, index value 1, here this is the n by 2. Okay, here the value is, it is n by 2, so we are passing the n by 2 is here, uh, 2 we are passing. So the, as per the algorithm I am telling, right? So this is n by 2 based upon this tree, based upon this tree, n is the 5, so 5 by 2 is n by 2 is 2.5, floor value is 2, so we are taking the 2. Now left of I, 2I, what is the left of 2I? So this is the I, 2I is 4, so 4 is the index here, LE. Right of I, right of I is here 2I plus 1, so 2I plus 1 is, so 2 into 2, 4 plus 1 is 5, so here 5 is the index. So now we are checking, left index is 4 less than or equal to n is 5, here n is 5, so it is true. Then a of le, a of le is here, the value a of le is 8, so 8 greater than a of I is here the index value 2, so here the 10, so 8 greater than 10, it is false. If it is false, else portion will execute. In the else portion, I is the value assigned into the variable largest, so index value 2 is the largest value here. The when you are comparing the 8 and 10, so 10 is the largest, so that is the meaning here. The index value to 10 is the largest when comparing with index value for 8, right? Then if right child index is here 5, so 5 less than or equal to 5, yes it is true. A of right, so a of 5 is 16, so 16 greater than a of largest. What is the largest index? 2, so a of largest is here 10, okay, index value to 10. So 16 greater than 10. If 16 greater than 10 is true, so if it is true, that means child is greater than the parent. That is the meaning here. Child, right child value, okay, 16 is right child value 16 is greater than the parent 10. That is the meaning here. If it is the case, the right child will be assigned as a right child index is assigned as a largest. So right child index 5 is assigned as a largest index. If the 5 not equal to I value is here true. So now this is true actually. If it is true, we have to swap a of I, a of 2, a of 2 is here 10. We have to swap the 10 comma a of largest. A of largest index is 5. What is the value available in the 5? So 16. So we have to swap 10 comma 16. So a of uh, 2, the I is 2 here, then here largest is 5. So we are exchanging the value a of 2 comma a of 5. A of 2 is 10, a of 5 is 16. So we are going to swap 10 comma 16. When you are swapping the 10 comma 16, this will become 14, 10 and 16. It will come 16, then here 3, so here 8, then here it will be 16. So this is what given here. You look at that. So when you are swapping the 10 and 16, so 16 will become as a parent, then 10 is becoming as a child. Still it is not satisfying the heap property. So right heap property is here parent should be always greater than child value, but here 16 is less than the 14, so it is not satisfying the heap property. So if it is not satisfying the heap property, we have to swap 14 and 16. Here again we have to pass the value. Now n by 2 is decremented by 1. N by 2, initially we have passed here 2 is the index value n by 2, right here. N is the n is the value we have passed here is 5. So now here we are passing that value here n by 2. Here we have to take the 1. Okay, we have to take the 1, right? So when you are passing the 1, we have to take left of I. So 2, you look at that. Left of I, so when you are passing the I value is 1, left of I here 2, left of I is here 2, right of I is here 3. So 2I plus 1. Then so this is checking LE less than or equal to n. So n is here we are taking 5. Okay, so n less than or equal to 5. So we are checking. So this is based upon this one. This is based upon this step for loop. Okay, so now we are checking less than LE index is 2. So 2 less than or equal to 5, true. A of LE is 16. So 16 greater than A of I is 14. So 16 greater than 14. Yes, both are true. If it is true, then this line will execute. Largest will be left index value is 2. So 2 is the largest index, so else portion will not execute. Now we are checking the right child index is 3. So 3 less than or equal to 5. So 3 less than or equal to 5. Yes, it is condition true. A of R is 3. 3 greater than A of largest. Which is the largest here? Index number 2. So this one. Okay, we are checking 16. Okay, 3 greater than 16. This become false. Once it become false, this will not execute. Then now this if loop, largest index, which is the largest index? 2. Largest value available in the index 2. So we are checking 2 not equal to 2 not equal to I. What is the I value here? 2 2 is here. I value is here 1. I value is here 1. So here 2 not equal to 1. Yes, condition is true. If it is this case, we are swapping A of I. A of I is here 14. So we are swapping the 14 comma a of largest index is 2. So in the 2 we are having the value 16, so we are swapping the 14 comma 16. Here we are swapping the 14 comma 16, we are getting uh, 16 is the parent and 14 is the child. Now it is satisfying the it is satisfying the heap property. Again we will call this one a comma largest. So here largest value is here, index value is 1. Index value is 1. So when you are calling max heapify, again what we will do, so here for loop will be decremented by 1. So here the I value is 1. When you are decrementing the I value from the 1, it will become 0. So 0 greater than or equal to 1. So condition is false. So once condition is false, it come out of the loop. So this is the way to apply the heap property to adjust the value uh, uh, between the child and parent.